Hello everyone and welcome back. Today's video wasn't really planned because initially I thought I will continue with my memory expansion boards for the All64. Unfortunately, due to a series of unfortunate events, well, Creative retracted the permission that they gave me initially to use the Sound Blaster logo. But not everything is lost because I'm still in talks with them and I think I need another 2 weeks to really figure out what's going on. If I will not be able to use the logo as it is right now, that's fine. I will just create new boards without the Sound Blaster and All64 logo on it. I'll just have my channel logo and then we'll continue from there. And you will see that I'm also working on a smaller version of the memory expansion board, but this is topic for another video. So, what are we going to talk about today? It is the MIDI FORGE Maestro. And as I said, I didn't plan this video because I have one last revision coming my way. This is revision 1.3. And yeah, it has a flaw which prevents it from working correctly. So yeah, it should be resolved in revision 1.4 and it is fixable on these boards as well. But obviously I want to have a bug-free board. The MIDI FORGE Maestro is a wavetable board and I already made a video about this. So we are not talking about the details what this board can do, but today I will show you how to assemble one of these boards to get a one slot solution. And you can see here now all these components are really close to the MIDI FORGE Maestro PCB. I think the highest point are the buttons compared to this previous version. You see there are still the pin headers that have this plastic spacer in between. This is gone here. And also the Raspberry Pi sits a lot closer to the PCB. So this one here should be able to clip on your sound card. Like here I have a ESS audio drive. So if I plug this onto this card, like this. Yeah, so here you can see it is most likely not going to interfere with any neighboring adjacent PCI or ISA expansion card. But of course you have to double check because sometimes you have longer pins on these cards and there are metal surfaces exposed which could short some pins. You still have to verify that you're not shorting anything. So today will be the official launch and the instruction video how to build this board. In my previous video, I already explained the MT32Pi project. I explained how to configure it and so on. So if you want to learn more about this, please go and have a look at my previous video. And I think that's about it. Let's just start with the assembly process of this PCB. But before we get there, I would like to thank today's video sponsor, Flux.ai. Now you have seen that I designed quite a few boards in the past 2 to 3 months. And in order to do that, you need a design software that allows you to design PCBs. And Flux.ai could be your AI-powered PCB design software. Flux.ai runs in your browser, so you don't need to install any software packages on your system. Once you're done with the schematic, you can head over to the PCB layout designer and move the components into the place you want them to be. You can also start routing the traces. But if you don't want to do that, you can use the auto layout function. Flux.ai comes with an AI-powered assistant that can do the routing for you. And then Copilot creates all the traces that are necessary to connect all these components together. No need for you to sit there and draw all these traces by hand. And then you can have a look at your board in 3D and how it will look like. And you can ask questions about your design. Copilot is a valuable resource while designing your PCBs. It's always good to have a second opinion. So, if you're thinking about creating a PCB for your next project, give Flux.ai a try. Links are in the video description. So what do you need to build one of these one-slot MIDI FORGE Maestro boards? Let's start here. So here are all the mandatory components that is necessary to get this board running. These two are optional and we get to these ones in a moment. So this one here is a 13 pin times 2 pin header. These are 2.54 millimeter pitch size. This is the connector that goes onto the sound card. And initially I got one that is a through-hole component, but unfortunately due to the space limitations that we had with this board, I had to bend these pins outward. They are good enough so that they fit through one of these boards easily and can be soldered from the top, like this. Then we need a few SMD components. Here you see 3 small pieces. The first one is a 22 microfarad capacitor, tantalum. Then you have a 10 kilo ohm resistor and a 20 kilo ohm resistor. Then we have our DAC. This is the digital to analog converter. It comes with a 3.5mm headphone jack, which you have to remove if you want to get the one slot solution. And then you have the screens. I have two here because some of them come with a pin header already soldered to it. So if you can get one where the pin header is not soldered to it, that's much easier than to assemble this board. So this one here is no longer needed. Also this one here we don't need. We have 4 buttons here. By the way, I will link all the parts that you need where I bought them from. All of this is from AliExpress. And then you can just follow the links and you get exactly to the items that I show you here. Now this one here is our connector for the front panel. This is an SMD pin header that is, well, 90 degree. If you never plan on connecting a front panel, you don't need to put this, but I will put it anyway because, well, we can test some screens. And now let's go to an optional component. Maybe this one also should be here in the optional components. This here is a larger screen, and you can hook up a larger screen to the front panel. So yeah, we'll hook up one of these later. So the 4 buttons I already mentioned. This one here is a simple switch. It can switch 2 lines at the same time. This is important. The switch is here. So you can switch between the screen that is on board and the screen that is on the front panel. Because the protocol that is used here, it cannot address 2 screens at the same time. You have to pick the one that should be active. And you cannot switch the screens while the system is running. So yeah, this is more or less just a configuration which screen you want to use. And then we have some pin headers. This one here is the one for the Raspberry Pi, which is here. It's also a mandatory component. So yeah, we need a Raspberry Pi. And then we have 3 more SMD pin headers. So they just look like this. I'll show you later how to get rid of this plastic spacer. So there is one 6-pin and 2 4-pin connectors, and they don't come like this. So I had to order longer, I think 40-pin rows, and then I have to cut them to size. And this is pretty much it when it comes to assembling this board. The last thing that you need is a SD card which has the MT32 Pi project on it and configured. If you want to look through the configuration, please look at my previous video. I show some of them there, including how to change the configuration for the rotary encoder, which is the last optional component that I have here. We had a look at this one that allowed you to easily adjust the volume and switch between either the different synthesizers, so MT32 or sound fonts, or switch between the individual sound fonts or the ROMs for the MT32. One more thing, I will not solder this with a soldering iron. I will use solder paste to attach all these components to the MIDI FORGE Maestro board. But first, let me show you what I do to get rid of this plastic spacer. I just simply push these pins through the plastic spacer so I have less of resistance when I try to pull it completely off these pins, and then it looks like this. And this is what I will solder to the board. For these small ones with 4 pins, you can just push down on the plastic and it will just do all of them at the same time. When I was working on this, I found that it was really easy to just place this pin header over the edge of my workboard here, and then I can just press the pins through the plastic. Okay, and then this is our pin header for the Raspberry Pi. So yeah, this is ready to be soldered. Okay, and next up is the component placement. I'm specifically not using a microscope today because not everybody has one, and I will show you that it's possible to place all these components without a microscope. Now we just need to make sure that these connectors are placed nicely in the center. It is not as important for the Raspberry Pi connector. It is important for these two, because if you don't place them correctly, then your DAC will not properly fit on top of it. Done. Let's move on to the next component. Let's place our switch for the screens. This is this one here. Now let's place the SMD components, the tantalum capacitor, which is already here. Here's our 20K resistor and a 10K resistor. Make sure that the tantalum capacitor lines up, so the line indicates the plus. So you have to make sure that this one also lines up with a plus. Next, I want to place the duct connectors, and these ones are a little bit difficult to place because, well, they're aligned in an L shape and they have to be well aligned, otherwise, well, you will not be able to put the duct over it. Now let's continue with the screen. This one is not as crucial because, well, we have nothing else connecting to the screen, so these 4 pin headers are literally the only thing that we need to worry about. Okay, now let's place our buttons. And finally, we only have to add our front panel connector. Sometimes this connector needs a little bit of extra solder because, well, it's tilting forward. Most of the time it's okay. And this is it. When I applied solder paste, I also put paste over these pads that are for the pin header that clips over the sound card. That's not a problem. Once I'm done with the soldering of these components, I can place the pin header afterwards and just resolder all these pins with a soldering iron. Now let's solder these components to the PCB. Okay, and here is our soldered board. First thing I have to do is I have to get rid of these plastic spacers. So let's see, some of them are going off really easy. Like this one here, you can already see. Yep. Once we put the screen over these pins, we have to cut off the excess. Okay, so for all pins go through the plastic, that's good. Oh, and I think the plastic is off. And hey, there you go. Nice. Let me see if our Raspberry Pi fits over these pin headers. Oh, there you go. Perfect. So yeah, this Raspberry Pi sits very close to the board now. And then I'll also solder this connector to the PCB. And then I'll see you once this goes through the hole here. There we go. And I'll see you once all of this is complete. And this MIDI FORGE Maestro is assembled. Now the only thing that we still have to do is to cut off the excess of those pins. And here we are. All the pins are cut, and this is a 1-slot solution. Now the only thing that's left is an SD card with an MT32 Pi project on it. So here's already one that's pre-configured. For the local screen to be selected, I have to change the position of the switch to down, as indicated here with this half arrow down. And this is all what we need to do. So these are all the pins that I cut off. Now we can plug this Wavetable board onto one of my sound cards, like this ESS audio drive here, and it should just work. Okay, let's see if this MIDI Forge powers on. Yes, it does. So let's quickly check if all the functions are there, and then we'll test a different screen. And I will show you how to switch between two different screens, the onboard screen and the external screen. So I'll use X-Wing because here I can set up the soundboard as Gemeral-MIDI with Sound Blaster. And this is what we need to play MIDI music using sound fonts. And this is what the MIDI FORGE Maestro is capable of doing. It provides wavetable sound. So we'll leave this at Gemeral-MIDI. And let's see if the MIDI FORGE Maestro works. And the MIDI FORGE Maestro is working. So now let me just quickly go through the buttons. Let's switch between sound fonts and MT32. Works. Let's switch between sound fonts. So I'm looping through sound fonts now. I have two sound fonts on this SD card. Okay, that works as well. So it loaded the other sound font. Let's go back. Okay, perfect. Now let's see if we can change the volume. Perfect, works as well. Let's try MT32. Let's change to a different ROM. Okay, this one looks like it works too. And volume works as well. So great, all functions are working. Now let me power off. Now let's switch the screen. Now currently we have the local screen selected. Let me change this to the external screen. And that's it. So I already hooked up a screen here. And what we should see now is that this external screen should have all the image data. So the onboard screen should be blank, basically. Let's try that. Oh. I didn't know I have a blue screen. So let's quickly go into X-Wing and verify that the screen also plays the music and we can control the Maestro with the buttons. Okay, and this looks like it works too. So, yeah, what else is there? I guess let's try a bigger screen. The larger screen has exactly the same pinout, so you can just swap out the small screen with a big screen, but we need to change a setting in the MT32Pi project. So you have to open the mt32pi.cfg file, and then under LCD, you can set everything related to our OLED display. And here we see our width and our height. So instead of 32, we just put in there 64. And that's it. Now save, and the only thing that we have to do is replace the screen. Make sure that the polarity is correct, and then we can try this. Okay, so now let's try real MT32. Yeah, okay. And this is all I have for you today. I hope you enjoyed it. Now, where can you get this board? Of course, the PCBs are available on PCBWay's shared project space. I will have a link in the video description. There's another link that points to a post on my website. This post has some additional information. It has the links to the MT32 Pi project. There will be all the links to the parts that we have seen today that I soldered to the Maestro PCB. So yeah, the post on my website will be the one source where you can get all this information. Now, of course, if you do not want to deal with any of this and you still want a board like this, send me an email. I will sell these boards for $100 each. And as before, I think I haven't mentioned this, but this price includes shipping. My email is now on the screen, but you will also find all this information on my website in this one post. Now, of course, I'm interested what you think about this project, and if you're interested in getting one of these MIDI FORGE Maestro boards. I'm very happy that I finally managed to get this board down to the size that we have a one-slot solution. It is a little bit more tricky to assemble one of these boards because with the plastic spacer removed, those pins are a lot less stable. So if you touch one of these pins too long with a soldering iron, you are going to move it off the pad. So yeah, there is a downside to this. But you get the benefit of having a one-slot solution. Finally, I want to thank Flux for sponsoring this video. I also want to thank all my Patreons who are already supporting my work and this channel. If you want to support my work, you can head over to Patreon and pick one of the paid membership tiers. And as a Patreon, you will also get some insights on future projects I am working on. You'll always be a little step ahead. But of course, this is also a great way to communicate with me. So, this is everything I have for you today. Thank you so much for your time. Thanks for watching. And I will see you in one of my future videos. Take care and bye bye.